Hey, what's up? It's Jake, and in this next section, we're going to go over a workflow for deploying infrastructure as code. The workflow looks strikingly similar to deploying application code, but there's a few subtle differences we're going to go over. So, just like we did in our other one, we're going to use version control. We're going to run the code locally. We're going to make code changes, submit the changes for review, run automated tests, and then we're going to merge and release, and then deploy. Exact same steps. However, version control, a little bit different. You've got a live repo, you got your modules repo that we went over. So you'll have a place to stage modules, and then your live environment, you might have, prod, dev, test, stage, whatever, and then have different variables established on your main files where you import an actual Terraform module, and it uses those variables to deploy infrastructure. And your infrastructure may look wildly different depending on which environment you're pushing to. So you want to keep that in mind, whereas your application code might be the same but on a different version number. So and that can be kind of similar, but you definitely want two separate version control repositories for your repo for live infrastructure, and then a repo for all of your modules. Okay, because those modules could be used all over the place, but you definitely don't want them in the same repo. In that case, you can actually work on your modules with different versions and have um, your imported modules on a specific version, so that you can iterate and change that modules repo without actually pushing things to the production repo. That's kind of the idea. So then you have the kind of the golden rule of Terraform, which is healthier Terraform if you go into your live repository. If you pick several folders at random and just run Terraform plan, the output should always be no changes, right? It means everything in your code matches exactly what's deployed. But every now and then you'll see something is different and someone's like, oh yeah, I forgot, I did this thing or I did that thing or whatever. Or it might fail completely for some strange reason. Um, and in a worst case scenario, you get some huge diff because something's gone and you don't know why. So the gold standard is really whatever you're aiming for. The master branch of the live repo should be a one-to-one representation of what's actually deployed in production. So it's actually deployed, like whatever's in there, whatever's out there in the cloud. We've been using AWS. Whatever AWS resources you have should be exactly the same all the time. You might need to do some kind of drift control schedule to make sure, run a Terraform plan, automatically on a schedule to come back and be like, hey, this is always the same. Because it's great that you can check, but like you kind of want to check pretty often. But if you go through a quick scan, whatever of your live environment, you should absolutely every single time be able to match all the resources one to one, no changes to make. Okay. And then your master branch, what's actually deployed should be your master branch. Some people call it main. That means all the changes that affects production should go directly into master, and everything should be off of that. And Terraform apply should be no exception to that. So there is a trouble with branches because of locks. And you want to make sure that if you have two team members running Terraform apply, at no point do they actually ever overwrite each other. That solves one problem, but even though Terraform backends do allow for locks for state, they can't help you with locking at the level of the code itself. So if two team members deploy the same code to the same environment, but from different branches, you'll actually get into conflicts with locks and get into conflicts that locks actually can't help you with. So we'll give you an example. So let's say that I deploy changes on an app to an EC2 instance, right? And then another person on a different branch deploys changes to the same EC2 instance. Well, because I run a Terraform plan and the other person runs a Terraform plan, everything might look good and you deploy them to a staging environment. In the meantime, somebody else comes along, a third person in there, makes changes to the Terraform config or the same app but on a different branch, and let's say they do something like change the tag. My changes might already be deployed, because they're on a different branch, but the other guy's changes will be set to the old value, the tag value. So when that other person runs the plan, they'll actually undo the changes that had just happened, because it's the same resource, but your Terraform code's on a different branch. So you're going to have two different lock files on Terraform state, which is why I always recommend using the same state file with locks. Now, because the locking, like I used in DynamoDB, is sequential, it's still possible for a person in one branch to overwrite changes of a person in another branch without knowing that that person had just changed it. They might go, oh, this is different. I need to change it back. So you got to be really careful with that, because locking from Terraform back end in that case does not help, because the conflict has nothing to do with concurrent modifications to a state file. It's really applying changes, and it could be like days, weeks, whatever apart. And it'd be the same problem, because the underlying problem here is that branching is bad for infrastructure as code. So if you're trying to implicitly map code to infrastructure, like wherever in any cloud, you'd never want to use a branch. For shared environments, always deploy a single branch. So trunk-based development, or whatever you want to call it, is definitely where you want to be with infrastructure as code. So do not, and I'll say it one more time, do not branch your infrastructure as code repositories. Okay. And if you need to explain it to somebody, the short version is, because even though locking isn't an issue, and the state files will be fine, but you're pointing to the same environment, you can have two different branches that don't know that they're updating the same environment because they're using two different lock files. So anyways, yeah, enough on that. Running code locally. So you want to have a developer account in an AWS environment that you can do like I did with TerraTest and be like, hey, deploy this, do a test, destroy it, and then let me know what happens. Should have some kind of sandbox dedicated to that kind of stuff. And you should have one for every developer, because if I'm trying to do something, again, it's like branching, and you have another developer trying to do something, and we go into the same environment, and I'm just running a VPC, and he's trying to create a load balancer, like it's just going to be a nightmare. So make sure they have separate sandbox environments. So for making code changes, you can iteratively make changes just like you do with application code. Just make sure you rerun Terraform apply and deploy all those changes, and just test them real quick. No big deal. The TerraTest stuff does make the feedback loop faster. Like you saw, I did mine in 214 seconds, as opposed to waiting for the init, waiting for the apply, opening AWS console, or not really have to open AWS console, but copying and pasting the DNS, going to a browser, waiting to see, okay, does it work? Cool. Somebody asked me a question, and I end up talking to them, and then we have coffee, and then we complain about something, and I come back 30 minutes later, and I go, oh yeah, I need to destroy this, or I forget to destroy it. In this case, it's all automated. It's very easy to do. Submitting changes for review. This is kind of the same thing. Once your code's working as you expect, you create a pull request, you get your code reviewed, just like you would with application code. Not much to go over there. You need to make sure you have some kind of standard for documentation and your file layout and your style guide and all that stuff. So that'll have to be defined internally, but you definitely want to have something in place. Okay. And I won't get into the details of that. Automated tests, we just went over that. TerraTest is kind of the way to go with that. There's not a whole lot you can do, so we can write unit tests, integration, end-to-end, whatever for your code. But there's one other one you should do, and that's always run a plan before you run the apply. It shows the plan automatically when you run apply, so what it really means is you should always pause and read the plan. So if all you do is run Terraform apply and you don't run plan first, just make sure you read it and don't just type yes. Okay. So just take the second and read it. Make sure you're looking at what it is that you're trying to do. You can even store it in an output file. You can be like Terraform plan to this file, and then you can open the file and read it if you want to read it or whatever. Have somebody else read it. I don't know, whatever you want to do. Merge and release, you saw me in my example of using Git, how to do Git tags. So you can Git push follow tags and then keep your versions up to date and declare your versions like I do, like in my main file where I say, hey, use this, and it just uses the latest one in like a different environment, like prod, for example. I don't know if I have a prod here, but you might have, where did I put it? Live, prod, here, somewhere in here. Anyways, you can, here we go. You can actually put like, hey, go to this repo and get this module, but get this version, that kind of stuff. So you definitely want to tag your resources by version or whatever you're doing. Version's the easiest way to do it. Follow your tags and make sure you're using the right versions everywhere where you're deploying stuff. Application code, you have to have a separate artifact to deploy, like a Docker image or a VM or something like that. Terraform natively supports downloading code from Git, so you can just use that tag and you're good to go. So you don't need to worry about images or container registries or anything like that. And then the last part's deploying. So you have an immutable versioned artifact, you have time to deploy it, and there's a few things you need to consider. One, your development tooling. Terraform itself is the main tool. However, you might want to check out like Atlantis or TerraGrunt, Terraform Enterprise, some kind of, if you want to do Python scripts or Ruby or Bash or whatever scripts, if you're into that kind of thing. You can do that. And then your deployment strategy. So whatever that is, like I said, there's different, how many retries do you want to do, Terraform state errors, releasing locks, just whatever your deployment stat, like however you plan to do that, having a rollback plan, all the regular deployment stuff, pretty similar to application code. And deployment server. So just like you do application code, infrastructure code changes should be applied from a central, like continuous integration server, not from your computer. So you should have a CI server that runs Terraform, and you can use that like Jenkins or Atlantis or whatever you want to use. But yeah, you definitely want to have a single place. It gives you the same benefit with application code. It kind of forces you to fully automate your deployment process. Ensures they always happen from a consistent environment. It gives you better control over permissions and access to production, that kind of stuff. So you definitely want to do that. And then promoting artifacts across environments. So just with application artifacts, you'll want to promote any version infrastructure you had from environment to environment. So like version whatever in dev to stage to prod. Just follow this rule, and that's always test Terraform changes in pre-prod before prod. Kind of common sense, right? So yeah, so that's pretty much it. If you have any questions, let me know. But if not, then I will go ahead and put it all together in this last video.